Welcome to my channel Math with Nazia. In this video we are going to learn about cube roots. Cubes and cube roots are inversely variable. So for example, if you take 3 cubes, so 3 cube is equal to 27. You can inversely write this as cubic root of 27 equals 3. Both are correct. So now let's see the first example. Let's take a smaller number first. So cubic root of 64. So cubic root of 64 can be written as 4 times 4 times 4. So since there are 3 4s, we will take it 1 4 outside. So the cubic root of 64 is 4. I have already taught you in square root, instead of 2 numbers we will take 1 number outside, but in cube root instead of 3 numbers we will take 1 number outside. So the cubic root of 64 is 4. You can also verify that 4 cube is 64. So you will come to know that your answer is right. So now let's see the second example, which is, let's take a little bigger number, cubic root of 3375. So to find the cubic root of 3375, we will do the prime factorization method. I think you remember the prime factorization method. I have already explained prime factorization method in my previous video for square roots. So let's start doing it. So if you have any queries or any doubts for prime factorization method, you can refer the previous video. The link is given below in the description. So 3375 is divisible by 5 because the last number is 5. So this is 675. So 675 can be further divisible by 5. So if it is further divisible by 5, we get 135. 135 is also further divisible by 5. So we get it as 27. Now 27 is not divisible by 5, but 27 is divisible by 3. So we can take 3. 3 times 9 is 27, and 9 can be further divisible by 3. So 3 times 3. And 3 can be further divisible by 3, so 3 times 1. So now we have done the prime factorization method. So the cubic root of 3375 is cubic root of, we have 3 5s, 5 times 5 times 5, and we have 3 3s, 3 times 3 times 3. So as I told in the previous question, instead of 3 5s I'll take 1 5 outside, and instead of 3 3s I'll take 1 3 outside. So 5 times 3 is 15. So the cubic root of 3375 is 15. So isn't it easy? We just need to do the prime factorization method. Now let's see the third example for today. Pause. Now let's see the third example for today, which is cubic root of 1728. Now let's start doing the prime factorization method. The number is 1728, and since it is an even number, we can always start with 2. So whenever we have an even number, we will always start it with 2. So when we do it by 2, we get it as, so when we divide 1728 by 2, we get it as 864. So 864 can be further divisible by 2. Yes, because it's an even number. So we get it as 432. 432 can be further divisible by 2. So we get it as 216. Right. So 216 can be further divisible by 2 because it's an even number. So when it is divisible by 2, 2 times 1 is 2. And see, usually all the students make a mistake. Since there is a 1, it's not divisible. We have to put a 0. Usually everyone skip this 0. So put a 0 and then take it as 16. So this becomes 108. So now this can be further divisible by 2, which is 54. 54 is again an even number which will be further divisible by 2. This will become 27. Now let's see whether 27 is divisible by 2. No, 27 is not divisible by 2 because it's an odd number. So let's divide it by 3. So 3 times 9 is 27. 9 can be further divisible by 3. We get it as 3, and 3 can be further divisible by 3. We get it as 1. So we have done the prime factorization method. So this is cube root of, there are 6 2's here, 2 times 1, 2, 3, 4, 5, 6 2's and 3 3's here. So as I told you in the previous video, instead of 3 2's I'll take 1 2 outside, and instead of another 3 2's I'll take another 2 outside, and then instead of 3 3's I'll take 1 3 outside. So 2 times 2 is 4, 4 times 3 is 12. So our answer is 12. Isn't it easy to find the cube root? So if you have any queries regarding the cube root, you can comment down in the comment section, and for more tips and tricks, do like and subscribe to my channel. Thank you.